Okay, guys, it seems that we can start. Hi, everyone. Today we'll have a very interesting lecture where Artem Tisleyev will tell us about GraphQL and REST, what suits you better. The presentation will take approximately 30 minutes. After that, we'll have time for your questions, so feel free to raise your hand and ask or questions or chat or in chat. And yeah, that's all from my side. I pass the microphone to Artem and we can start.
Yep, thank you. Hey everyone, appreciate you coming. My name is Artem and I'm a senior software engineer. I joined our BiggyPalm family in November 2021. And I strongly agree with the phrase that sharing is caring. So today I'd like to contribute towards it and talk with you about GraphQL and REST API architectures and approaches that lies within this topic. Before we start, I'd like to ask those of you who have a practical experience with GraphQL to raise your hands using the team tools. So I know I could form a feeling of audience better. So yeah, if you have some practical experience with GraphQL, just let us know. Let's give it a few seconds. Alrighty. So I see some hand raises. That's perfect. Now these people are going to be responsible for spotting mistakes on the slides that I initially put into the presentation. All right. So please make a note when you see them so we could apply corresponding fixes at the end. Thank you. I feel like I need to explain why I even chose this topic. So the reason for that is that I believe that all of us were in a situation when you have a problem to solve and a list of tools that can actually help you with that. Usually the tricky part is to make the correct decision with the tool, right? So knowing the tool's strengths, weaknesses, costs, trade-offs between one and another helps us out. And considering that working with APIs is one of the most common thing in web development, I decided to pick two popular tools and try to compare them so we'd have one less comparison to worry about when making decisions in this field in the future. All right. Okay, let's dive into it. First, to quickly synchronize our vocabularies. No one can get away without definitions, right? So what is REST? I'm more than sure that all of us already aware, but yeah, REST is a set of architectural constraints, not a protocol or standard, and API developers can actually implement REST in a variety of ways. But when we thinking about RESTful API, it basically like comes to an examples when a client request is made via API like that. It transfers a representation of the state of the resource to the requester or endpoint. So this information or representation is delivered in one of the several formats via HTTP. Most popular one is JSON, of course, because it is language agnostic and let's say friendly to read by humans, and of course machines can read it as well. On the next picture, you can see one of the common things how it works with REST. So, for example, we can get fields related to user object. Yeah, we can then use that ID to retrieve posts. Then we can make another request to extract followers of that user. So basic things. So we can probably just skip and go to the next guy in the room, and it is GraphQL. And GraphQL, it is actually just a query language for your API and a server-side runtime for executing queries using a type system you define for your data. It provides a way for a client to request and receive data from a server in a flexible and efficient manner. In GraphQL, the client specifies exactly what data it needs, and the server returns only the data, allowing for a more efficient exchange between client and server. Spoiler, arguably, yeah, because there are some hidden stones. So now you see that I'm okay with reading things written on my screen, right? So these skills are covered. Let's dive more into a more interesting part, non-related to definitions. So just a quick overview, how does GraphQL work? It basically resolves around three most important components, like queries, mutations, resolvers, and a schema. Queries is the process of fetching data from the GraphQL server. Mutations is the process of writing and modifying data on the GraphQL server. Resolvers, since server don't know what to do with the incoming queries, resolvers act as an assistant by telling GraphQL where and how to fetch data corresponding to a given field. And schema basically describes the functionality a client can utilize when it is connected to a GraphQL server. By the way, the fact that I forgot to do mutations as a separate item here is not an intended mistake that we spoke about at the start, so ignore that. Now let's see how it looks. Like the same thing that we did with REST in the previous example picture, that's how it looks in GraphQL. So on top, you can see a query where we provide user's ID and the fields that we want to retrieve based on the provided data. So yes, it is one single request, and yes, it does return the JSON as you see below. I think I forgot to click slides for you on that screen. Apologies for that. You have a control over it, so hopefully you did that. Yeah, but the final picture that we just talked about is this one. Let's give it a second and then move forward. Alrighty. So when it comes to comparison of the tools, you need to understand pros and cons of each other. Yeah, so no one is ideal in this world. So let's start with REST and see what is good at and where it's actually not. So REST. What are the main advantages of using REST APIs? Let's start with that. Okay. So pros are the following, and we are starting with it's easy to understand. Easier to adapt to REST principles while building an API since it uses HTTP methods, and most of them, like most of the HTTP verbs, are pretty self-explanatory and easy to understand. So that's a good thing. Next one is popularity. Like there is no doubt that a dominant API infrastructure in the market is still REST, and REST still stands out as the most widely used architectural style for web services due to its rich ecosystem. Yeah, compared to GraphQL, it still continues to be popular architectural style. It is scalable indeed, since there is a separation between the client and server. It's easier for different teams to work on different parts of the application. This allows for the application to be scaled by the development team without increasing its complexity. Like the most thing that I like the most is caching. Minimizes multiple trips to the server. When a client makes a request to the server, it checks first for the cache, and if the cache exists, it will not proceed to the server. And caching in REST acts as an intermediary layer since frequent queries are stored for reusability. Another thing is data formats. So REST APIs can handle many types of data requests in multiple data formats. We know that. And code encapsulation is more interesting that because when REST is used as an architectural style for API design, it allows for code encapsulation. This means that a particular piece of code that is part of an application can be concealed while displaying the rest of it to the client. And communication-wise, it is actually nice that REST API communicates via HTTP status codes to let us know if the request was successful or whether an error was encountered. The status codes are grouped into the 5 classes. They are well-known one, like informational responses are hundreds, successful responses 200s, redirection messages are 300s, client error responses 400s, and server error responses 500s. But yeah, as we said, no one is ideal. Yeah, the first one and basically the main one when it comes to mind when you compare things like REST and GraphQL is overfetching and underfetching. So the biggest drawback in REST API is that it is highly like vulnerable to overfetching and underfetching. It's when we get more data than it is actually required for our clients. For example, when we need a list of characters related to a TV series, we do not need every information related to these characters, right? Similarly, when it comes to overfetching, a particular endpoint might not give the required information. So this leads to calling two endpoints for one view, thus slowing down the response of an application. Another thing is versioning. So APIs can have different versions due to compatibility issues. However, more versions of an API makes the code less maintainable. Again, arguably, there are a lot of techniques how to deal with versioning correctly so that they won't cause you a lot of pain, but it is still considered as one of the drawbacks that REST has. And like one more is limited bandwidth. So to process a bigger payload, you will need a network pipe with a higher bandwidth capacity. So REST can only be used when the constraints of a network bandwidth are limited. I didn't have practical experience with this particular issue. I know if any one of you did, but yeah, for this part, I just know that it exists, so decided to put it here anyway. But yeah, I didn't have that particular issue before. Okay, so there are a lot of pros and cons for REST. Spoiler alert, same goes with GraphQL. So let's take a look on it. When it comes to GraphQL, of course, I will put first that it basically solves the over and underfetching problem, because unlike REST, GraphQL sends a single query to the server according to the data requirements, and the server then responds with a JSON object when the requirements are fulfilled. So with GraphQL, it returns the requested data according to the needs for the client, hence minimizing network and memory use for clients. You remember that example after the definitions that we had on slides. So that basically demonstrates it. You can check them by taking a look on a few slides back. Okay, then schema and type system. So GraphQL is strongly typed with, which means that it allows users the type of data that is available and the form it exists in. The thingy related to protocol agnostic is that although GraphQL typically serves over HTTP, it isn't the only choice when it comes to client-server communication, since it is agnostic to the transport layer, so it can be something else. You could use any protocol as long as you can retrieve or manipulate a piece of data. This is useful scenarios where WebSockets can be used for real-time updates instead of HTTP. So GraphQL is perfectly capable of that. Quick response time, again, arguably, because there are some scenarios where your response may not be as quick as you'd like. But yeah, since you can combine multiple requests together and get the exact data using a single endpoint, it lowers the latency time, resulting in a quick response time. So flexibility with GraphQL, you can add new fields and data types without worrying about changing the front-end code or creating a new version for your API, which is quite handy in practice. And those of you who are experienced, have a practical experience with GraphQL, can probably relate to that. And we're moving into the introspection. So to know more information about the type of queries supported in the schema, GraphQL introduces a feature known as introspection. So with this feature, developers can see the queries, types, fields, and directives that are supported in the current schema. Through introspection, you don't have to worry about API documentation since the document is generated automatically. Yeah, I could probably put additional emoji on next to that one because it is very handy when it comes to GraphQL that basically correctly written code generates all the documentation for you in a accessible way, and it is also friendly for your clients to read this documentation, and it is more time efficient to do it this way compared to REST, in my subjective opinion. So yeah, this is nice thing. We are moving to rapid development on the front end, which is related. Yeah. Under REST API, front-end developers usually need to wait for backend developers to efficiently develop the API. Through the GraphQL approach, front-end developers don't need to wait for an endpoint from a backend developer and can retrieve the exact content according to the queries. So you can basically you can say that, okay, in REST we can also mock the response of that particular request legit, but then in GraphQL, so if you like Google those examples on how to do that together with your front-end team, you will see a difference, and you can basically mock way more data without worrying how it will be retrieved, like with 3 requests, with 2 requests. No, only 1 request, and all the data that client needs, it will be already there. So the real-time data is the last one on the list of prompts, is apart from queries and mutations, GraphQL also supports another operation time like subscriptions. With subscriptions, you can fetch data each time there is an update in the result. So this is particularly useful when building real-time applications, as clients are notified about ongoing changes. So yep, GraphQL handles this part as well. But then again, you may see that I'm like kind of biased to GraphQL, but on practice I'm not, because it is the list of its disadvantages probably bigger than REST. So let's take a look at those. First one is error reporting. So the queries will always return an HTTP status code 200, regardless of whether the query was successful or not. And it brings additional responsibility for you to handle this error reporting, while REST basically does it for you with those HTTP status codes. So when it comes to security, when working for an API, GraphQL lets you query your requests according to your needs. On the one hand, it gives enormous power to the clients. It has, on the other hand, it has security implications, since complex queries can overload your server and network, those exposing yourself to DOS attacks and bad things like that. So it is like a good thing and not a good thing at the same time. So be aware of that. And N+1 problem. One of the common pitfalls when dealing with GraphQL performance is n+1 problem. So the reason developers are prone to this issue is because GraphQL executes a separate resolver function for every field. So due to the nested data, servers will need to make multiple unnecessary round trips to the data store. So this is not the case in REST, as there is one resolver for every endpoint by default. And the most annoying one for me personally is caching. So caching, GraphQL lacks the inbuilt caching system, since it does not follow the HTTP specifications and instead uses a single endpoint. Since it doesn't have a cache support of its own, GraphQL will need to rely on external library like, for example, there is FileMentQL to provide client-side as well as server-side caching solutions. Alternatively, there is a CDN such as GraphCDN. It can be used to scale as well as protect your API from random traffic spikes, database troubles, and downtime. So yeah, would be nice, and maybe in the future it will be built in, but currently you need to rely on some additional tools, unfortunately. Introspection. So while introspection has its advantages, introspection is the thing related to documentation that we spoke about earlier. So one must So while introspection has its advantages, one must be extremely cautious when implementing the mechanisms of introspection, especially in production mode, as it can reveal the backend created by developers, such as arguments, fields, types, descriptions, etc. So if the entire backend is exposed, attackers could retrieve fields that are normally not accessible for users. To be fair, it is an easy workaround. You just need to hide that particular endpoint that you can use in order to access that schema, and you should be fine. Of course, it's still more accessible in many terms compared to REST, but yeah, obviously, just don't leave it open for world. Now, complexity. Yes, GraphQL can be a bit complex to understand, as it has a steep learning curve compared to REST, and is best suited for companies that are dealing with rapidly changing data and have the resources to re-architect their API platforms. Also, if you worked with GraphQL and try to upload files, here we go, file uploading. Uploading files to GraphQL API is not a straightforward task, since there isn't much information about it in the official GraphQL documentation. Maybe they already added some, didn't check. And one might have to consider switching for REST. For that, the file needs to be uploaded via REST endpoints, and the resulting URL would then be passed to the GraphQL mutation. Alternatively, it is possible to upload files through a Polo server, which is, in my opinion, more popular approach, via third-party library like GraphQL Upload, for example. And even though we talked about the performance increases when it comes to solving the problem of overfetching or underfetching, it's still an issue with GraphQL. Like complex queries could slow down the performance of an application. And to process each request, GraphQL would have to impose an additional time cost. So solution to counter the performance issue, it is possible to use a native GraphQL database such as dgraph to handle millisecond query response time, even on complex queries. Didn't do that myself, and hopefully you won't have to as well, because as long as you use GraphQL for the correct purposes, like most of the things, same as with REST, yeah, most of the things that are listed as cons, you won't need to deal with them. And for that, we are switching to a question how to make a decision, right? So even though there are a lot of things that you can just see, put an answer into this question, and it will help you to move forward, there is no final recipe. We all know that. So let's see what I found based on my practical experience and information from the internet. So understanding the differences will be a first thing, pretty obvious one. So let's jump in straight to the next one because, yeah, evaluating your use case. Basically, this step, the goal of the step is to evaluate your use case. If you have a simple API that only needs to perform CRUD operations on a small set of resources, then REST might be the better option. On the other hand, if you have a complex API that needs to support a wide range of queries and searches, then GraphQL might be the better option. So next step is to analyzing data relationships. So this factor is basically related to the fact that GraphQL is designed to handle complex data relationships, while REST can sometimes become unwieldy when dealing with complex data structures. So if your API has a lot of relationships between your data, then GraphQL might be the better option. We should probably play a game how much I will say might be a better option in this slide, but yeah. So determine your client requirements. The client requirements for your API should also be considered, of course, and put almost on the number one spot. I don't know why I have it on the point D, but okay. So if you have a large number of clients with different requirements, then GraphQL might be the better option as it allows each client to request only the data they need. However, if you have a limited number of clients with similar requirements, then REST might be the better option. So the learning curve, you need to evaluate it as well. And yeah, REST is a widely adopted standard, and many developers are familiar with it. And GraphQL, on the other hand, is a relatively new technology, and it may require more time and effort to learn for you and your team. The three next ones are more interesting to me personally. So client versus server-driven development. One more factor to consider is that so REST is a server-driven architecture, which means that the server defines the resources and endpoints that clients can access. GraphQL, on the other hand, is a client-driven architecture where the client specifies the data they need and the server responds with the data. So if your team prefers a server-driven approach, then REST might be the better option. But if they prefer a client-driven approach, then GraphQL is your choice. Arguably, again. Analytics. Okay. So analytics is actually a lot of application have built-in analytics tools in place, of course. So REST APIs generate a lot of data that can be easily tracked and analyzed using tools like Google Analytics. On the other hand, GraphQL APIs can be more challenging to analyze as the client specifies the data they need, which can vary widely. So if analytics is a priority for your API, then sorry, GraphQL just not analytics friendly. Maybe there are some workarounds that companies put into place for their own uses, but yeah, analytics and GraphQL, not good. And yeah, last but not least, the budget. GraphQL can require more upfront development effort and may require more resources to set up, maintain, and scale than REST. If your budget is limited, then REST might be the better option. However, if you have the budget to invest into development and maintenance of a GraphQL API, it may provide long-term benefits in terms of flexibility and efficiency if previous options on the list were into the GraphQL favor, of course. Okay. Okay. So looks like we're done. And by the way, there were no mistakes on the slides. I just wanted you to stay engaged during the presentation, not fall asleep. But if you spotted something suspicious, by all means, bring it into the questions. And I'm putting a big question mark at the end of the end, because obviously there will be way more factors that you need to consider when doing these choices. REST and GraphQL are not the only options. So of course, this is not a final recipe, as I said before. And of course, this thingy, I couldn't resist but put it into the slide, the final one. So thank you so much for your time. And I believe, Boris, we can jump into the questions section if we have any.
Yeah, thank you, Artem. Thank you for great presentation. And guys, yeah, we have chance to ask a question. And I see one question from Dima. Feel free to ask a question in chat. I will read it. Dima?
So thank you very much for the presentation. It was really good. My question is about this N+1 problem. So there are actually some techniques to deal with it. There are some tools like batching, but honestly, I have quite limited experience with GraphQL. I tried them, and it kind of like they can solve the problem, but it's always much more it requires much more efforts to implement them when comparing to, for example, Rails, where you just write includes and everything works. So the question is, what's your opinion on those tools? And maybe you had some experience with them. How hard are they to implement those techniques?
Right, that's a really good one. So I will put this link in the chat. That's basically a gem provided by Shopify, GraphQL badge. And I believe that this is particularly a thing that can resolve your problem. I hope I did not mess it with another link. Yeah. Okay, context. The GraphQL supports a lot of languages, yeah, and the thing that I just linked is Ruby specific, meaning that you can just dive more into it, check the usage, check what kind of problems it solves. I used it in the past, yes. Was it hard? No, setting up GraphQL initially was not a fun job to do for the first time, but using the gem that basically tells you how to solve N+1 problem, it's not hard. And you just need to make sure that you identify this problem first. So that is, in my opinion, the hardest part. So once the problem is identified, the tool is there for you. And I believe that in GraphQL community, and if you are joining a project that already worked on GraphQL, you will most likely have those examples already in place, how to solve these problems. But yeah, very good shout about the GraphQL batch gem. It's really a tool to solve this problem. Simple as that. Yep, thank you. I see one more from Andy. So do you have any thoughts, experience on the gRPC as an alternative to REST? No, I do not. But when I was preparing the material for the presentation, my browser was suggesting versus gRPC when I was trying to type GraphQL. So I believe that's a thing, but my answer is no, unfortunately.
Yeah, thank you. That's going to be a thing for the next presentation, I suppose.
Sounds good. We have one more from Evgeny.
Yeah, just on my camera. Yeah, thanks again for this presentation. That was awesome. Yeah, it was really great prepared content. I have a few questions. One is a simple one. Is about versioning. Does GraphQL support it?
Well, technically, at some point, you can have a version of a application, yeah, that is like living in a separate pull request with GraphQL schemas rebranded. changed, etc. But in the world of REST, like under the same way that REST has versioning, as far as I know, GraphQL doesn't. And it simply means that you don't need to deal with it at all. Like you can deprecate fields on the fly by adding those comments to the fields itself in your Ruby application. And but the versioning in general, I dare to answer no. But if someone had to deal with them, like in GraphQL, by all means, just share with us.
So you mean we don't need this versioning?
No. In GraphQL, no. Like there is a single endpoint, one version of it, and you just use it by your clients should use it, and you develop your resolvers around it within the same version, like initial one. You have only one schema basically in GraphQL. It's not the case that you can have like a schema A for version 1 or schema B for version 2, etc. You just have only one schema that defines your types, fields, etc., and you work with that.
But what if we want to have a big release and change everything in the schema?
I would suggest not to have this kind of releases at all.
Okay. Okay, got it. And my second question is about practice. Maybe you, Artem, or someone else who worked with GraphQL have real cases why your project choose GraphQL instead of REST. Or maybe if you migrate from REST to GraphQL, and what were the reasons?
Maybe someone from audience would like to answer. That would be more interesting if I will be answering that. But if we don't have anyone, I can try myself. All right, I'll try myself. So I had this experience on one of my projects in past, and like long story short, my subjective opinion was that we were looking for some trends that like tools that Shopify was using, right? Shopify was one of those, and still one of those examples that has that uses Ruby on Rails, and different technologies around it. So they do have a lot of GraphQL related gems in place. They are basically providing it for Ruby community, and it was considered as a trend. Yeah, currently you can weight in different factors, try to make a proper solution, but sometimes you just need to follow with like trends, especially when big companies like that do that. Of course, prior analysis is required, so you should understand if it's even applicable to you, right? And is it fit for your budget, etc. But yeah, it was the case in that project, and we also like wanted to speed up the interaction between backend and frontend, right? So we had a separate frontend, like not teams but developers, and like the amount of interactions, like in my again subjective opinion, was reduced. Maybe some teams like that were working alongside it wasn't the case, but in ours it was just easy, right? I simply create a mocked version of what client expects, and they can query whatever they want and do not overfetch, do not underfetch this data. So, right, it's basically might differ from company to company, from project to project, but in reality is that like try it with your pet project and see how it feels. Like, does it feel different? Ideally, you should try it with you if you have a front-end friend. A friend who has a pet project related to front end, right? And you develop a backend for them. So basically, do it in REST, do it in GraphQL, compare. That will be the best thing that you can potentially do. Like, no matter how many presentations you hear about, watch videos, etc., obviously practice beats it a lot. So just give it a shot when you have time.
So yeah, my My inner feeling regarding this is also that the main reason is about performance. I guess you agree with this point. I mean, to use GraphQL.
Right. I'll be honest. I didn't see any metrics for performance. Like, hey guys, 1 year ago we had REST, and this is our metrics, like the memory consumption, etc. Now we have implemented GraphQL, and this is the result for 3 months of usage. Like, I didn't see a diagram like that. Maybe there are some in the internet, but yeah, as were mentioned in some of the slides, you still need to be careful with GraphQL when it comes to performance, because if your query is like complex, you may still have your resolvers that are written in Ruby not be very efficient, because you still need to retrieve data from database. Yeah, and let's say 3 separate REST endpoints compared to one pretty complex and hard to understand GraphQL resolver. So you might prefer 3 REST requests instead of 1 GraphQL. Yep.
Yeah. Thank you. Makes sense.
All right.
Right. It seems to me we don't have any questions.
Mm-hmm.
Okay, thank you guys. Thank you, Artem, for great presentation. We'll send you, guys, presentation, Artem presentation, and this recording. So, yeah, and feel free to feel feedback from this session.
Yep. Thank you so much, everyone.